everyone, welcome to our channel. Let your friends subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your physics for class 11, that has been the part 1 which we have to cover up here. On the same behalf of it, this has been the classes your class 7 and that we had done is your class 6 and the last classes where we had done your unit 1 which has been the physical world, and for the important question with the topics of scope and excitement physics and about related toward this unit. Coming towards in the last classes, we had started with unit 2 which is in the units and measurement. So we had started with SI with quantities and the units. We'll continue from there only, but before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. So we go for the same. So starting with the base quantities. Base quantity, then we have your this has been for SI units. Here we have first column for in that is your name, then we have your symbol, and of course then we have your definitions for God that we have done. Okay, on the same phases we talk about here only, and for the same we talk here and that we discuss here in the detail about it. So let's find it out, and that what we have to discuss here, which is about we had done your length, mass, time and electric current in the last classes. Today we'll continue from the thermodynamic temperature, and that what we'll have to discuss here. Thermodynamic temperature that we have here, for the same it will be, the name we have is your Kelvin, and for the symbol that is being used for the Kelvin here is being K. So that the definition for the same is the Kelvin is the fraction of 1 upon, I'll just write it down for you all. The Kelvin is the fraction 1 upon 273.16 of the thermodynamic temperature of the triple point of water, which is we have to talk about it, and then your which is of 1967. So for the same we go for the next, and that we discuss about your which is the amount of substance that we have here. In that has been the name is your the side unit for the same is mole, being represented by mole, and the definition is that the mole is the amount of the substance of a system which contained as many elementary entities as there are atoms in 0.0112 kilogram of carbon 12 here. Isn't it your the mole is the amount of substance of a system which contain as many elementary entities as there are atoms in 0.012 kilogram of carbon-12 in 1971. Okay, now we go for the next. So the next we have here is the luminous intensity. And for the same, it is being your the name is your candela. This has been CD. And the definition for the same, it is the candela is the luminous intensity in a given directions of a source that emits a monochromatic radiations of frequency. The candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency that has been 540 into 10 to the power 12 hertz, and that has a radiant intensity in that direction of 1 upon 683 volt per steradian, which is in 1979. Okay, so for the same we discuss about SI based quantities and the units, which is of course being important one that we have to discuss here. Now we discuss moreover related to this only, that is about these type of questions that we have to discuss here. So now for the same we go for the another table here as well, which has been related to the some units that retained for a general use through the outside SI that we have to discuss here, and of course that is being that has been important here. So we go for the same, you just write it down and you can copy it down for the same as well. We'll discuss some units retained for general use. Okay, the through outside table SI we talk about for the same. And so here we go, this has been the name, then we have your symbol, then of course we have your value in SI unit. So we go for the same, here it has been the name, then we have your symbols, and of course then we have your values in SI unit. Discuss for the same. The first name we have is your minute, and the symbol is MIN. The value in SI unit is 60 second. Then we have hour, this is represented by H. We have 60 minute equals to 3600 seconds. Then we have your day, is being denoted by D. 24 hours is equals to 86,400 seconds. Then again we have your air, it's been y 365.25 day equals to 3.156 into 10 to the power 7 s. Then for talking about degree, is equals, that has been representing like this, and so 1 degree equals to pi by 180 radi. Then we have your liter, and for the liter it will be representing as L, and 1 tm cube equals to 10 to the power minus 3 meter cube here. Then another we have your ton, that is being representing for T, it has been 10 to the power 3 kg. Then again we have a caret, and that is being representing by capital C. Then we have small c, and then it will be your 200 mg. Again we have bar, it has been representing by bar, and 0.1 MPa equals to 10 to the power 5 Pa. Then we have your Curie, it is being representing by Ci, the value we have 3.7 into 10 to the power 10 second inverse. Then again we have your Roentgen, that is being for R, capital R, which is being 2.58 into 10 to the power minus 4 that kg. Then we have again we'll discuss about that is being after the Roentgen we have to discuss about quintil, so we discuss about it. So after the Roentgen we have a quintil. For quintil it is being representing by small q, the value is 100 kg. Then we have your barn, in barn that is being denoted by small b, it is 100 fm square is equals to 10 to the power minus 28 meters square. Then again we have here is the another one is arc, it been representing a 1 dam square equals to 10 to the power 2 meters square. Hectare, HA, which is HM square equals to 10 to the power 4 meters square. Then we have your standard atmospheric pressure, it has been denoted by ATM, which has been 1013225 Pa equals to 1.013 into 10 to the power 5 Pa, that we have here. Now we discuss here, and on the same behalf of it, you have to note that when a mole is used, then elementary entities must be specified, and these entities may be atoms, molecules, ions, electrons, and that other particles or specified groups of such particles as well. We employ units for some physical quantities that can be derived from the 7 base units, and that is some derived units in the terms of SI base units that is being used, and some SI derived units that are given for the spatial names, and some derived SI units that make use of these units with spatial names, and then 7 base units as well. These are the given that we'll discuss for that in the references, and then other units that retain in the general use that we discussed here. For the same, that the common SI prefixes and symbols that for multiples and submultiples that are given in we'll discuss later, and then general guidelines for the using the symbol for physical quantities, the chemical elements and nuclides that are of those of SI units, and there's some other units that are given in for your guidance and for the ready references as well. Now we'll discuss the many more here, and we'll continue with the measurement of length here. We'll discuss about here, which is about the measurement of length. In terms of measurement of length, it will be discussed here. So for the same, it will be you already familiar with some direct methods for the measurement of length. And for example, a meter scale is being used for the length from 10 to the power 3 to 10 to the power 2 meter, and a vernier's caliper that is being used for the length to measure an accuracy of 10 to the power 4 minus 4 meter, and a screw gauge is being the spherometer that can be used to measure the lengths that are less as to 10 to the power minus 5 meter. To measure the length beyond these ranges, we make use of the some special indirect method as well. And for measurements of length, well, first we'll discuss about the first one. For the same, it has been the measurement of large distances. Measurement of large distances. In measurement of the large distances, such as the distance of a planet or a star from the Earth that cannot be measured directly with a meter scale. An important method in such cases is called the parallax method. And when you hold a pencil in front of you against some specific point on the background, like a wall, and look at a pencil first through your left eyes, then you're closing the right eyes, and then look at the pencil through your right eye B, then closing the left eye, you would notice that the positions of the pencil seems to change with respect to the point or on a wall. So the distance is a parallax. That distance is a parallax, and this is called parallax. The distance between the 2 points of observation is called a basis, and in example that the basis is the distance between the eyes here. To measure the distance d for the far away for the planet S, and by the parallax method, you observe it from the two different positions that is your observatories A and B on the Earth, that is separated by a distance AB, and at the same time that will be shown. We measure the angle between the two directions along which the planet is viewed, and at these 2 points, that angle ASB that represented by the symbol theta is called a parallax angle or a parallactic angle as well. As a planet is very far away, so B upon D that is being lesser than 1, and that is being therefore that the theta is very small, and then we approximately take an AB of an arc that is length of B of A of a circle with the center S, and that distance D with the radius AS is equals to BS, and that so that AB equals to B, which is equals to D theta, where theta is in the radius. So we represent that here in the form of D equals to B upon theta. So we draw for the same here. Of course, that has been the useful, and that has been the necessary too. This is from the S, A and B. This is B, this has been the D, this has been theta. This is parallax method. Yeah. So these having determined D, that we can be a similar method that to determine the size of angular diameter of a planet. If D is the diameter of the planet and alpha is the angular size of the planet, then the angle that is subtended by D at the Earth that we have is which has been alpha equals to D upon capital D, which is being here, that's been representing. And for the same here, that the angle alpha that can be measured from the same location on the Earth, and it is the angle between the two directions when two diametrically opposite points of a planet that are viewed through the telescope. Since D is known and the diameter D is of the planet, that can be determined using the equations that we had done. Now we go for the same one question that we'll deal with in respect towards it, and that is of course being the important one here. So we go for the same. The question is, Calculate the angle that is of 1 degree, and then 1 minute of arc and arc minute, and then 1 second of arc or arc second in radian, and use 360 degree equals to 2 pi, and radian 1 degree equals to 60 minutes, and then 1 minute equals to 60 seconds here. So we go for the same, doing one by one. Calculate the angle of, first we'll have to discuss about 1 degree. So for the same we go, we have 360 degree equals to 2 pi rad. It is 1 degree equals to pi upon 180 radian equals to 1.745 into 10 to the power minus 2 radian. Next we go for the next, that has been the for B, which has been 1 minute of arc or arc min. So for the same we talk about it here. 1 degree equals to 60 minutes equals to 1.745 into 10 to the power minus 2 rad, which is equals to 1 minute equals to 2.908 into 10 to the power minus 4 radian equals to 2.91 into 10 to the power minus 4 radian. Next we talk about for the same here, the another one that has been the C part and of this only, which has been 1 that minute that we have here, second of arc or arc second in radians, use 360 degree equals to 2 pi radian, which has been 1 degree equals to 60 minutes and 1 minute equals to 60 seconds. So we talk for the same here, which has been for 1 minute equals to 1 minute 60 seconds 2.908 into 10 to the power minus 4 radian, and 1 seconds equals to 4.847 into 10 to the power minus 4 radian, which is equals to 4.85 into 10 to the power minus 6 radian. Okay, that we have here, that what even though we have to discuss about it. So we have to discuss many more that we have here, then many more questions as well that we have to discuss here, but here we're gonna end up with this, and we'll discuss the rest of the questions, that's the rest of the classes in the next coming classes. But before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So now with that has been with ending it up, before ending it up, other than physics we had done your sociology and software engineering. Even though we had done your which has been we had done your chemistry for class 11 part 1, and we have chemistry 12 part 1 as well, which is in that we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8 with the conversions, logarithms and antilogs. We had done ER diagram, we had done even though English PHP interview questions, English vocabulary, and that is general knowledge and important facts about the countries as well. In terms of coming towards reasoning, we had done your reasoning. In that we had done general mental ability, logic reasoning of verbal reasoning, and in non-verbal reasoning we had done series, analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completion of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, draw situation, constructions of squares and triangles, figure formation analysis, and of course practice question set as well. In terms of it, we had even though started with CBNST. In that we had done your unit 1, unit 2, unit 3, unit 4, and unit of we have to cover up. Unit 3rd we are in, and in terms of it we had to cover up that has been the quantitative aptitude we had started with, and that we had started with arithmetical ability, and that we had done operations on numbers, SCF and SCF of numbers, decimal fractions, simplifications, square roots and cube roots, problems on numbers, forms on ages, stats and indices, percentage, profit and loss that we are dealing with, and then we are ratio proportion. In terms of chemistry, we have started with chemistry 11 part 2, which is being we have started with redox reaction. You can just go ahead for the like, share and subscribe. Now we continue with part 1 physics that we are started with. In that we had completed your chapter 1, which is in the physical world, which is your what is physics we had done, and your scope and excitement of physics, physics, technology and society, fundamental forces in nature, nature of a physical law. In chapter 2, which we had done, and we had started with units and measurement. In here we had done introduction, the international systems of unit, measurements of length, measurements of masses, measurement of time we have to cover up. Measurement of length we had even started with. I have to do many more questions, numericals with reference towards this. Then after that we'll start discussing about measurement of mass, measurement of time, accuracy, precisions and instruments, and the error in that measurement, and significant figures, dimensions of physical quantities, dimensions of formula and the dimensional equation, dimensional analysis and application as well. In unit 3 we have to cover up the motion in a straight line, which has been the introduction, position, path length and displacement, average velocity and average speed, instantaneous velocity and speed, acceleration, kinematic equation for the uniformly accelerated motions, and your relative velocity as well. In unit 4 we have to cover the motion in a plane, which has been introduction, scalar and vector, multiplication of a vector by a real number, additions and subtractions that is of vector, graphical method, resolutions of vectors, then a vector addition, analytical method, motion in a plane with a constant acceleration, relative velocity in a 2-dimension, projectile motion, uniform circular motion. In unit 5 we have to cover the laws of motion, which is the introduction, Aristotle fallacy, the laws of inertia, and then Newton's first law of motion, Newton's second law of motion, Newton's third law of motion, conservations of momentum, equilibrium of a particle, common forces to mechanics, circular motion, solving problems in mechanics. In chapter 6 we have to cover the work, energy and power, which has been introduction, notion of the worlds and kinetic energy, the world energy theorem, work, kinetic energy, work done by a variable force, the work energy theorem for a variable forces, the concept of potential energy, the conservation of mechanical energy, the potential energy of a spring, various forms of energy, the law of conservation of energy, power and collision. In unit 7 we have to cover out the system of particles and rotational motion, which has been introduction, center of mass, motion of center of mass, linear momentum of a system, the system of particles, vector product of the two vectors, angular velocity and acceleration with the linear velocity, torque and angular momentum, equilibrium of a rigid body, moment of inertia, theorem of perpendicular and parallel axis, kinematics of the rotational motions about a fixed axis, dynamic of rotational motions about a fixed axis, angular momentum in the case of the rotational about a fixed axis, rolling motion as well. In chapter 8 we have to cover the gravitation, which has been introduction, Kepler's law, universal law of gravitation, the gravitational constant, acceleration due to the gravity of the earth, acceleration due to the gravity below and above the surface of, gravitation, potential energy, escape speed, earth satellite, energy of orbiting satellite, a geostationary and a polar satellite, and weightlessness as well. So here we gonna end up with, and yeah, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than this, completing after this unit 8, we'll start discussing about unit 2, which has been part 2, which is of unit 9. From there we'll have to discuss, of course, and stay tuned with us, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Whatever the subject you required of, whatever the topic you required of, you can just tell me in the comment section. We'll be surely help you out from that. And yes, the ER diagrams that those who had requested for, we will surely be providing you soon as well. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you.